All right. Well, hello, everyone. Like Alex said, my name is Joshua Bin, Director of Data and Digital Scholarship here at Baylor. And let me go ahead and add to the chat here the URL to this sort of walkthrough. This is one of the first times that I'm going to attempt with all of your help, of course, attempt to lead a hands-on webinar instead of doing it in person. So we'll see how that goes. And then we also have Christina Clonch from Sam Houston State University who's going to assist on chat. You're definitely welcome to either follow along on your computer or just sort of watch at this point. There we go. But if you do want to follow along, we will want to make certain that you have some version of Tableau Desktop installed on your computer. That can either be Tableau Public, which is entirely free, or it can be Tableau Professional. There are versions that will give you 12-month licenses with no cost for teachers and students. Librarians are kind of in that gray area. Sometimes I've seen when librarians request an instructor license, they grant it, and other times they do not. But Tableau Public will work great. So now that that's all said, this is a webinar on showcasing the GIS and mapping capabilities of Tableau, either public or professional, does not matter for this workshop, this webinar. And as a case study to use as an example, we're going to be mapping the 2016 presidential election data. I failed to put that in the title, but we're gonna focus on Texas because all of us should be in Texas library. Because this is designed to, at least for some of us, to be hands-on, there's no need to hold questions until the end, especially if it's a technical issue. So go ahead and if you run into any issues or have any questions, write them in the chat. And if it warrants me pausing and catching you up, let's go ahead and do that. I'd rather do that and get most of the way towards the end than to leave half or all of you behind. So this is an introductory webinar, hands-on experience generating interactive maps and map-centric dashboards. Let me go ahead and click on this, which is an example of the finished product. Why would you use Tableau? Why not use the very intuitive and easy to use graphing and visualization capabilities of Excel, for example? You would turn to a tool like Tableau. You can create, if you just need a visualization, a static visualization that you want to put in Word or PowerPoint. But the real benefit, the power of Tableau is that you can publish online browser-based dashboards like this one here that requires no software for the end user to be able to interact with. So that is the purpose, one of the primary purposes why I would turn to Tableau. And so this is an example of what we're setting out to create today. We have two maps. This is a county map of the counties in Texas. When you mouse over, it's giving us the name of the county and the median household income. We have a map of voter tabulation districts that we'll talk a little bit more about in a moment. As you can see, these are much smaller and more discrete. And this is giving us the income as we mouse over and of course we can zoom in. This is fully interactive. And this is giving us all of that data that we can see, also income. If we want to change the variable that we're seeing here on this dashboard, we can change this to percent who voted for Hillary Clinton in 2016. And I'll zoom out. So we can see with the legends on the bottom, the more gold is the low percent of votes, the more purple are the high percent of votes. And as we mouse over now it's showing us the percent of votes for Hillary Clinton. So we could see Dallas County was just about 60%. And then we'd be able to zoom in closer to see individual voter tabulation districts. So we can also change this to % Trump. So we're keeping it at 3 just to make certain that the webinar is manageable. So the color is basically inverse when you look at % for Clinton and % for Trump in 2016. We also have the ability, if we wanted to zoom in, let's say in the Austin area, drag a box, and it's going to filter both the highlight table and the county map to show us all of the counties and the % voted for Trump based on what we see here. The last capability that we're building in, let me go ahead and refresh this. The last capability that we're going to build in is a filter for the county so that we can go in and specify just want to see McLennan County. It'll go ahead and show me, this is the county or where Waco, where Baylor is. And I can go in and I can look to see in my county where did we have the preponderance of Clinton votes. We can look at the income. So this is what we're building. The end purpose is to create a browser-based dashboard that we can send to students, colleagues, staff, university leadership to give them the tools and capabilities to explore the data on their own. That's really the primary purpose for using Tableau Desktop. Now that that is done, we're going to go down and here are the links to install the software. We need data. There are 3 files that we're going to use. I'm going to click on this zip archive of all 3 files. I think I can. Can I? No, I don't remember how to do it. So if I click the zip archive of all 3 files, and we need to make certain that it's unzipped. So on my computer, I use pzip, but whatever software you have on your computer, and just extract it however you would typically unzip data. Go ahead and put this right on the desktop. Once it's unzipped, you'll see a folder that shows Tableau data. And inside that folder will be 2 Excel files, demographics, and a presidential 2016 election data. And this is a GIS shapefile. Before we explore some of those, let's talk about where these came from and what this data is. First, the Texas Voter Tabulation District shapefile is from the Texas Legislative Council. For years, they had an FTP server where we used to go and download all of this data, but now they've built into the Capitol Data Portal. So voter tabulation districts as a census equivalent of county election precincts, voting areas. So it's basically normalized precinct boundaries for census reporting purposes. And you can, if you wish, to download directly from here, but it's included already. Also, the 2016 general election data. This is also from the Capitol Data Portal and the Texas Legislative Council. And this file, President, Vice President, is where you'll be able to download for the 2016 election data. If you are not familiar with the Texas Legislative Council's offerings, they have an enormous amount of data, especially for redistricting, election data, going many years back. It's a really fantastic resource. Lastly is a few variables from the American Community Survey. and that's going to be the census data. What we're using is the 5-year 2012 to 2016, so that it matches up as well as possible with the 2016 general election data. So the first file that I want to explore is the demographics file here. And this isn't necessary per se for you to click on. I just want to make certain that we know what's in the file before we load it into Tableau. What we have is the unique county VTD number. So it specifies the county and then the voter tabulation district. The description of the county, then we have percent white, black, Asian, Hispanic, percent over 25 with a college degree, and the median household income. This is per VTD. So you can see, for example, all these Newton counties are different VTDs, so that if we want to aggregate or summarize for the county boundary, we'll need to sum, average, mean. We need to summarize these some way, and we're going to run into that very quickly in Tableau. So now that we've seen this file, the demographics, that's the first one that we're going to work with. And so now what we want to do is to fire up Tableau Desktop. I have the professional version here. The only two items that we're going to be using is Microsoft Excel and spatial file, like a shape file. But you will have, that's not what to click. You will have more or less, you can see all the different sources that we can pull in directly from into Tableau. If you have Tableau Public, you may not have all of these, but the two that we're using today are going to be Excel and spatial file. So when you first open Tableau, this is what you'll see. We're going to connect to that demographics file. So I'm going to specify Microsoft Excel and go to the desktop where I unzip the file and bring in the demographics. And what we see, and remember, if you are following along and your software or computer is not responding the way mine is, send a chat and Christina will either be able to help you immediately or bring it to my attention, and we'll get you squared away as quickly as possible. What we see now is we have the demographics table loaded, and it's giving us a preview of the data. It looks almost identical to how it looked in Excel. It's just showing us the first 1,000 rows so that it doesn't consume too much memory. What we want to do at this point, you can see that arrow that's pointing down into that orange sheet 1. And so we want to click on that to create a new sheet. The way Tableau is organized is each visualization type or object that you want to create has its own sheet. And then you can pull multiple sheets or visualization types together into a dashboard. So for example, if we wanted a pie chart, a tree map, a point map, and who knows what, a bubble map, pack bubbles, that would be 4 different visualization objects. We would create 4 sheets, 1 sheet for each object type. Then we can create a dashboard to pull them all together and make certain that they all are going to interact with each other the way that we want. So we are now in this first sheet. So we're going to play around a little bit, get used to the environment, but we're really going to build one particular visualization type in this sheet 1. I've got the printed off sort of instructions on that GitHub Pages site. So that's what I'm going to be following. So we are here in sheet 1. We want to create a tree map is the first thing that we're going to do. If you look all the way on the right, there will be a show me dropdown. You can click on that show me and it will turn visible or invisible. And these are all of the built-in visualization types that you can select from your available fields, and it will highlight telling you which visualization types that are built in. You can do a lot more than that are built in, but the built-in visualization types will highlight. You can click it and it will immediately display your data. You can see there's a dividing line between our variables. The top ones are have the blue icon and the bottom ones have green. These are numeric fields that they call measures, are the green variables, and the blue ones are categorical or qualitative fields that in Tableau speak is called dimensions. So these are our dimensions, these are our measures. What we want to do is to create a tree map based on the Hispanic population, percent Hispanic population per county. So I'm going to click county. Now on a PC, I'm holding control, but I think on a Mac, maybe you'd have to click something else, but I'm holding control and I'm going to select Hispanic, and I just let go of control. And you can see that various items have highlighted in the show me, including our two built-in point map and polygon map. But for our first example, I'm going to select this one here. And the way that I know it's a tree map is if you look down here, when you mouse over, it gives you the map type. And then what are the requirements? We can see it's highlighted. So I'm going to select tree map. And a tree map just gives us proportional squares and colors based on the values that are in it. So based on this initial attempt, we can see that Harris County, Bexar County, Dallas County, but we noticed something really weird, right? I don't know if you guys are seeing this as well, but remember that all of our data was in percents. So what we want to be seeing is the percent Hispanic in Harris County, Texas. It's saying is the largest, but the percent that it's giving us is 41,892. That is so not correct. Bexar County, they're saying is 40,310%. The reason why this is happening is how it's summarizing or aggregating all of the voter tabulation districts within each county. You can see here that it's for both the size of the box and the color of the box, it's summing. So it's adding up the percent Hispanic of all the voter tabulation districts within each county. And we don't want that. We want it to either average or median, whichever central value you want to specify. This gives us an opportunity here to look at the undo button. The undo within Tableau is phenomenal. You could be working for 3 or 4 hours and that undo will continue. It has no limit. It will go all the way back to an empty screen. Not all software is like that. And so I always appreciate that about Tableau. So I'm going to click undo and it's going to undo the tree map that we created. Then what I'm going to do is either right click on Hispanic, or you can click on this little drop down that appears on the right side of the pill, and default properties, aggregation, and this is specifying how we want it to aggregate or summarize the data. I'm going to pick the mean or the average, and I'm kind of slowing down a little bit in case folks are following along. Definitely much easier to see if people are following along when you're doing a live webinar. A live workshop. Now that I've adjusted the default summary for Hispanic, I'm going to do the exact same steps as before. So select county, hold control, select Hispanic, and pick the tree map. And now we can see that we do not have huge disparities, or not as huge a disparity as we saw initially. So we can see Starr County, I'm assuming, and we'll see when we pull these up, when we change the visualization to a map, we have 97.84% Hispanic, all the way down to Sabine County at 2.77%. So that's a tree map. At any point that we want to change the visualization type, super easy, we just need to show me. So if the show me is hidden, just click on the word show me. And I'm going to change it to this bottom right visual type that is called packed bubbles. And that's going to give us proportional bubbles. We can see that it is, I'm going to click on the show me to hide it. We can see that it's not taking up the entirety of my screen here. There's a drop down right above where I can change this from standard to fit the entire view so that it'll fit centered in my screen as well as possible. Unlike the tree map, we can see that it is specifying the average Hispanic is is driving the size of each of our bubbles, and the label, if it fits, is going to be the county. If we want to adjust the color, and this will apply to all visualization types you're working with, just drag whichever variable you would like to the color box. So I'm going to take Hispanic and drag it to color. And now, if you don't see the legend on the right, just hide that show me and the legend will appear. So we can see what the colors represent. But if you mouse over, of course, it's going to give us a lot more detail. If we want to change the color scheme, this kind of aqua blue may not be the ideal for what we're looking for. We can click directly on color and edit colors. And we have a pretty nice collection of built-in color schemes that we can use. So we can use these single or two color schemes. They also have these diverging schemes. The diverging are really useful for looking at outliers, those that are the most low and those that are the most high. I'll pick any you would like if you're following along. I'll pick the gold purple diverging. And now I can see gold is low, purple is high, and you can see with these diverging color schemes, the center is usually sort of washed out, like you can see here, because the diverging are really ideal for looking at those extremes. I want to see the lowest and the highest, and everything else just kind of gets washed out. All right, last thing we want to do while we're here at sheet 1 is I'm going to click on the show me. And I'm going to change this to the highlight table, which is the top right on my screen anyway. If yours, like mine, has 3 columns, it'll be the top right for highlight tables. And the reason why we're creating a highlight table, if you remember, we're creating this one that's going to appear right here, right? So we're creating, this is going to be one sheet. This will be another sheet. This will be a third sheet that will pull together into a dashboard. So right now it's showing us average Hispanic, but it's being sorted by the county. If we wanted to sort by the data value, you'll see right up here at the top, it has a sort descending. So I'm going to click this sort descending, and it's now sorted by the variable, which is the % Hispanic within each county. And it's calculated, of course, by averaging all of the % Hispanic within each voter tabulation district in this example. All right, let's go ahead and rename this sheet 1. So I'm going to right click on sheet 1 and I'm going to go to rename. I'm going to call that my highlight table. Then I'm going to duplicate this table, again by right-clicking, duplicate the sheet, again by right-clicking and duplicate. And so now we have 2 separate sheets. And I'm going to rename this new one, the rightmost one, I'm going to rename this county map. That's what we're going to finally, right? This is supposed to be a mapping GIS webinar. We're finally going to create our first map. So what we want to do is make certain the show me is visible. And I'm going to select, not the point, you can select the points if you wish, but I'm going to select the polygon, which is going to be simply the maps.
Hey, Josh,
Yeah.
we have a question for you.
Yeah.
They're asking if the current Hispanic map is trying to show % Hispanics in each county, which it is.
Yes, it is.
And then could you explain why we chose the average?
Well, we have multiple counties that make, multiple voter tabulation districts or voting precincts that make up each county. In this example, where we're working with all of our data is already on the VTD level, we need to find some way to aggregate or summarize all those individual pieces like a jigsaw puzzle, all those VTD pieces into each county. The default was to sum them or add them up, and we were getting thousands of percents because as it adds up, each of the percents of each VTD, the numbers were very high. So what we want is a more central value to represent the county percent Hispanic. We can select median, which would select, of course, the VTD whose percent Hispanic is in the middle of all of the percent Hispanic values in each VTD in the county. What I chose to do was to use the mean or average so that it just adds up all those jigsaw pieces, all those VTDs, and then divides by the number so that it gives me that central value. So for example, in Starr County, when you add up the percent Hispanic within each of their VTDs and then divide it by the number of VTDs in Starr County, we get 97.84%. And in Bexar County, with San Antonio, we get 56.54%. That makes sense? So that's why we did average. If I change this quickly to sum, oh, there we are. You can see sum of Hispanic is so high. Let's undo.
Thank you, Josh. That works great.
All right. So now I'm in, they look identical, our two sheets, but we're about to change the highlight table and the county map sheet into a map. So I'm going to click right on this icon, which will give us polygons, boundaries for each county, where this one would give us this would be useful for proportionally sized circles that would be placed in the center of each county. But I'm going to go ahead and use the polygon version. And we can see right away, this is expected, there's no errors, but we can see right away that not every county is filled in. In fact, it says here on the bottom that there's 99 that are not filled in. Of the 254 counties in Texas, 99 of them have counties in other states with the exact same name. What we used, if you remember, we used the name of the county from the Excel file, but we did not provide it with what state the counties were in. So 99 of them can potentially be in other states. So we can resolve that. Now, if we had another field in the file that listed the state, we can just point it to that state column, but we don't have that. None of our data here has a state. So I'm going to click on, left click, right on this 99 unknown, and I'm going to click Edit Locations. And so you see it says ambiguous because there must be at least one other Anderson County somewhere outside of Texas. So for the state or province, we don't have a field that specifies that. So I'm going to use fixed because all of our data is in Texas. So if I select fixed, Texas, and then OK, and everything is resolved. So this is showing us the percent Hispanic within each county, and just like we expected to see, highest on the border and less as it moves inland, looking at this county map. Next thing that we're going to look at is the at the very top here on your toolbar, map, and then map layers. And this is going to allow us to adjust what we have in the background or our base map. Right now it's set to the light style. And within each style, you'll have different options of what base map layers you can turn on or turn off. So for example, in the light style, I can turn on cities, and you see that they're toggling on and off. I can turn on county names if I wish, county borders, whatever sort of layers that we would like. There's also a normal, a dark, if you really want to focus on the colors and the data values. This streets one I really like. because it gives us a view, it gives me a view that I'm comfortable with. And I really like how when you zoom in, you get more of a street style like Google Maps, as opposed to some of the more washed out. So I'm going to leave mine on streets, but you can go ahead and you can set yours if you're following along to satellite view, an outdoor view where it'll look more at the topology, streets. And I'm going to click on the X here so that I get my layers back. Next thing that we're going to do is we're going to integrate the election data. So far, we've only been visualizing the demographics.xlsx file. I'm going to go back to the bottom left tab, which is the data source. And this is just how we left it with the demographic data. We're going to add a second file. Before I pull up that second file, take a look at it in Excel. So what we have here is the same county VTD number. So that's what we're going to use to create a relationship between our two tables. Then we have the percent who voted for Hillary Clinton, Johnson, Stein, Trump, percent write-ins, and the total number of votes. This is in the 2016 presidential election. Close this. So the way that we bring this in, you'll see there's an add here. And when I click on this ad, it gives me the choices that we had originally. I'm going to specify another Excel file. We'll do the GIS file, the shapefile last. I'm going to bring in the pres 2016.xlsx. And what it does is it adds the table right here. And I'm going to click this and I'm going to drag it into this white area. And just like this icon is showing, it's going to create a connection and allow us to define which fields to base the relationship on. So I'm going to take presidential, I'm going to drag it. You can see it's already connecting. I'm not doing anything to make that happen. And we have this edit relationship window that opens up. Every table and file that you bring into Tableau has to relate to each other in some way. Now, there's exceptions to that because we can do a full outer relationship where they have nothing in common. But without looking at the exceptions, the general rule is every file, whether it's spatial, tabular, or any type of file, has to relate to all of the other files in some way. So we can see it automatically detected. There's a county VTD column in demographics and a county VTD1 column in presidential. That's perfect. That's exactly what we saw in Excel. And now I'm going to go to back to the county map, and you'll see what looks different on the left. Now we have the demographics table with its blue dimensions and green measures, and the presidential table, it only has the one dimension, the county VTD number, and then all of its measures or all of its quantitative or numeric variables. We're going to go ahead and adjust this so that we can look at the percent votes for Trump in 2016 by county. We would do that by dragging Trump to color. Remember, anything you drag to color is going to drive what color is on our visualization, but of course it's going to default to sum. All measures will default to sum. So what I'm going to do is click on Clinton. I'm holding shift and then I'm going to click right in. So it selects all of those. And then I'm going to right click, default properties, aggregation, and change all of them to average. Now, all I need to do is drag Trump to color. And now we're looking at and we can see the color scheme on the right. Remember, if the show me is hiding it, just click show me. And we can see that it's going from light blue to dark blue. If we want to adjust the colors, very easy, just click color, edit colors, and we can use any of these drop downs that we would like. I should have mentioned earlier that notice when we created this county map, we didn't need to import a shapefile. That is because these are the built-in geographic boundaries. Apologies, should have mentioned this earlier, that are built into Tableau, and all you need is the unique identifier, and you don't need to bring in your own spatial file. So if you have airport codes, area codes, metropolitan areas, cities, congressional districts, countries, counties, some European, state, province, and zip codes, if your Excel file has any of these, then you can create maps and do all of your visualizations without bringing in any special shapefiles. The VTD is not on this list, and you'll see once we start working with the VTD file that Tableau support for shapefiles is pretty great, much better than a lot of its competitors like Power BI, for example. All right, so very easy. We want to change this to percent write-in, which of course is going to give us pretty washed out, but yeah, so we can see where we had percent write-ins, but it's maxing out at 1.747%. All right, so very easy. You see how we want to change the, let me make all of these. I'm selecting all of those as well. And I'm going to change all of them to the average so that at any time I can just drag. Now we're looking at percent white, looking at percent black, and then back to percent who voted for Trump in 2016. Now it's time to integrate the VTD boundary shapefile. Anytime you want to add data, you go back to data source, and we can see the relationship we have so far between demographics and presidential. I'm going to click add. This will be the third and final time, but this time I'm going to specify a spatial file. And you can see the various types. It can pull from GeoJSON, an Esri file geodatabase, a shapefile, GeoJSON, KML, MapInfo, TopoJSON. We're going to pull in from the shapefile, but you can see all the different file types that it can read from. Remember when we were looking at this in Explorer, all of these components make up one shapefile. The DBF are the attributes, projection information. The SHP is going to have all of the coordinates. But when we look at it through Tableau, it's only showing us the .shp. If any of those other files are deleted or renamed or moved, we may get an error. So you want to keep all those all the components of the shapefile together. Just like before, it shows us the file list here that is not already included in our data model. So I'm going to drag vtds.shp. And just like before, it's going to analyze the attributes and give me a suggestion. And it went ahead. We can see which fields are in here. And we definitely want the county VTD to the county VTD. And we're going to create a new sheet. We have our highlight table. We have our county map. You'll notice to the right of that are 3 buttons. The first little icon down here is a new worksheet. That's what I'm going to click, and I did. It created sheet 3. The icon to the right of that we're going to use in a little while is to create a dashboard. There is a third one. We're not going to cover that in this webinar, but that's a story. And what a story allows you to do is to combine multiple dashboards together into sort of a narrative or a story that you can guide the end user. But I'm in sheet 3, and now I've got 3 tables: my demographics, my presidential, and now my VTDs.shp. If you work with shapefiles, it is so easy in Tableau. All we have to do, every shapefile that you bring in is going to have a geometry field. Just double click it, and it will display your shapefile right on the map. Easy as that. Just double click the geometry field, which is in every shapefile that you import into Tableau, and it will automatically display your data. But if you're going to use Tableau, like I've been harping on, all of the aggregation issues and that you'd need to think through, we're seeing the same thing here. It is assuming by default that the level of detail or the aggregation level that you want to use to analyze these shapes is the whole thing at once. So when I'm mousing over, it's not highlighting or giving me information about a specific polygon or VTD. It's selecting the entire shapefile. So what we need to do is to adjust the level of detail is we need to drag a column that has a unique identifier to the detail box. And that's going to allow us to tell it what level of detail we want to explore this shapefile. So in the VTDs, it's the county VTD number. That's the unique identifier. I'm going to drag this to detail for the level of detail. And now you can see that we're highlighting and able to select individual polygons in our shapefile. And that step would be required if you're working with polygons, points, lines, whatever type of shapefile you import. Double click on geometry and then drag a unique identifier to the detail box. Now that that is done, let's see. We're going to map some data. We're going to map percent votes for Clinton from 2016. So we're going to take the percent votes for Clinton. We want to adjust the colors. We drag it to the color box. And there we are. So now it's showing our legend on the right. There is at least one VTD that voted 100% of the votes were for Clinton in 2016. But you can see in a lot of these urban areas that it looks foggy or dark or brown. It's not so much that the polygons are so small. They are small, but it's that the boundaries of the polygons are so close together that it's looking pretty dark and smudged in those areas. So what we want to do is just to remove the boundaries, the outline of each polygon. We can do that easily by clicking color. And you'll see here under border, it's set to automatic. If we change that to none, now we can see inside Metroplex, Austin, San Antonio, Houston. We can see inside those urban areas much clearer than we were able to before. And of course, if we want to change the color scheme, just click edit colors, pick whichever one you would like, and it's going to adjust with the legend on the right. Last thing we're going to do right here is to create a filter for which counties we want to view. That's very, very easy. First, we need to find the table that has the county field or column in it, and that's way up here under demographics. That's the one that has the name of the county. All we have to do is right click or click on the little drop down to the right and show filter. Now, when we publish this, the end user through the web browser is going to, of course, is going to have access to our visualizations. The mouse overs will be identical. Everything will be identical, but they won't have access to any of these things to the left of our visual. They won't have access to this or this. They will have access to and see everything that's on the right side. So right now, if we publish, they'd have the legend, and they would have a list of counties in a list box like this that they can go through and check or uncheck specific counties. And you can see they're vanishing as I uncheck. There is a little drop down hidden in the top right of this filter that gives you some options. And the main options we want to look at right here are these items. Right now it's giving us a list where the user can select multiple values. We probably don't want single value, but depending on what the purpose is, you can select single value. Single value dropdown means that you can only pick one county at a time now, but there is an all, which is nice. We can do multiple value dropdown, which I think is what I have on the default, right? Where it allows you to adjust multiple counties, but it doesn't take up all that space. It converts it into a dropdown. So that's what I'm going to select is the multiple values dropdown. It does give you, you'll see a text box that you can search in order to filter your counties. Let's see, it's 1146. There is an optional step here to create a dynamic dropdown to adjust the color. And let me talk through why that's important, and then we can decide whether we want to skip it and move on to the dashboard or go ahead and go through those steps. If you remember, the user, when you publish this, does not have access to any of these columns on the left. That means that there is no way for the end user through their browser to adjust this to income or percent Trump or Stein or percent Hispanic or college degree. They have no ability. We can do it just by dragging college degree to color, and boom, we now have college degree with our new legend. But that would be static. The end user does not have the ability to drag anything to the color box. That is not possible. So what is done is we can create a parameter which gives us a new control or a new dropdown with the items that we want in that dropdown. We then can create a temporary new calculated column. When I say temporary, it'll be there permanently, but the values in that column will be adjusted based on the dropdown. So for example, we could create a dropdown with the options of percent Clinton, percent Trump, and income. Then we create a calculated field that says if the dropdown is set to income, take the income column and copy it into this placeholder column. Or else, if they select percent Clinton, go ahead and grab the percent Clinton column and copy that into this column. And if we make that placeholder column and drag that to color, then that's going to allow us to give the end user the ability to, oh, it timed out, give the end user the ability to specify what they would like as a dropdown. I think we can do it fairly quickly. There's a little hidden dropdown right here. So the first thing I'm going to do is to create a parameter. A parameter is that dropdown that's going to allow the user to select something. So I'm going to call this choose variable. The items that are going to be in the drop-down menu are going to be text or strings, and I want to give the user a list. So I'm going to select income, and I'm going to push down on the arrow, down, percent Clinton, down, and percent Trump. So this is our parameter, and I'm going to click OK, and we're going to notice on the bottom left, underneath our tables, we now have a choose variable parameter that I can right-click and show parameter, not the top one. It's bolded, and people want to click it, but you want show parameter. Now I have a dropdown, and it's on the right side, so that means that when I publish this as a dashboard, the end users are going to be able to interact with it. But it doesn't do anything yet. Then I'm going to click on this little drop down again, and this time I'm going to create a calculated field. And I'm going to call this calculated field variable placeholder. And there are quite a bit of commands and tools that you can use. Again, there's two really great features of Tableau that keep me coming back to Tableau, even though some of the other tools have other capabilities. Its support for GIS shapefiles is fantastic, and it uses an abbreviated version of the old VBA, very easy to access, very intuitive language. I put inside of the instructions here that I've been following for us to copy and paste just to save time. So I'm going to copy this. I'm going to paste it here. So you can see it says choose variable, which is what I named this. So if choose variable equals income, then take the income column and copy it here. Else if choose variable equals percent Clinton, then that. Else if equals percent Trump, then Trump, and then end. It tells us that the calculation is valid, which is great. I'm going to click OK. And now you can see underneath tables, I now have this variable placeholder. If I drag that to color, oh, let me first set the default properties to average. And I'm going to drag that to color. Now I'm looking at % Trump. I'm looking at income and % Clinton. I apologize for speeding up at the end here, but I wanted to make certain that we saw how that was done. I'm going to rename sheet 3. I think the instruction said to do that earlier. VTD map. I'm going to go back to the county map. And instead of average Trump, I'm going to drag variable placeholder to the color. So now this also is going to be driven by that drop-down menu. And I'm going to do the same with the highlight table. I'm going to take the variable placeholder and drag that to color. And I dragged it to color, but the text, the values we're seeing are still the Hispanic. So I'm going to drag variable placeholder also to the label. And then I'm going to drag Hispanic away and make certain that's sorted correctly. So now I don't remember what the dropdown was set to, but the dropdown is now controlling all 3 of our sheets. This means that we are ready to use the middle icon down here, which is the new dashboard. And the default for the dashboard is it's going to suggest a particular fixed size, that it's going to be constrained to exactly that size. And that's useful if you're designing one for a desktop version, one for a mobile version, for example. But I found great success, instead of using a fixed size, to change it to automatic. What automatic will do, you see it's now the whole screen, is it will automatically attempt to adjust the dashboard based on the resolution of the screen that's viewing it. It's not always perfect, especially if you get really small, but it does a pretty good job. We can see our 3 sheets, and all we need to do is to, like it says, drag sheets here. The default is tiled, so that when I drag something, it's going to take up the entire area. Then when I take another sheet, and you see as I'm holding down the mouse and dragging it around, it's because it's set to tiled, it's asking me where it wants this new one. If it was floating, then you can drag anything anywhere you would like. Last is the VTD map. I'll put that here. Then we can adjust exactly how we want the sizes to fit. And remember, I can click highlight table and say I want to fit the width. You don't want entire view because then the height will also try and scrunch up. So I'm going to fit the width so it'll fit to whatever size. We can take out our calculators and try and get these to be exact as possible, but I'm going to leave this here so that you can see it works. I'm going to change this to income and all 3 update. There's a lot more we can do, but let's end this here. The next thing is, if you are using the professional version like I am, this is now just for the professional version, we need to create a data extract before we can publish to Tableau Public. Tableau Public, the server space, not Tableau Public, the software. It does get a little confusing. I need to create a data extract. This is not necessary if you're using Tableau Public software. To create a data extract, we go to Data, the name of the first data file that you brought in, which is demographics, and then Extract Data. I'm going to leave all these defaults. I'm going to click Extract. It's going to put it inside of the Tableau repository data sources. That works well. And once that is done, then if you're using Tableau Professional, then we can go to Tableau Server, Tableau Public, and save to Tableau Public as. It's going to prompt me to save the file first. So I'll call this book 1 delete so that I remember to delete this. And I'm going to save this locally. Then it's going to prompt me with, although it may, because I was rehearsing this earlier, I had logged in, but normally it will prompt you for your Tableau Public, which is entirely free, your Tableau Public account information. Before we explore this dashboard, if you're using Tableau Public, all you have to do, ignore the extract, I don't even think you have a server option up here. What you'll do, this is the only difference in the whole webinar. What you'll do is you'll hit File, and I think your only save is going to be Save to Tableau Public. That's your only option if you're using the public desktop version of the software. But either whatever desktop version you're using, we are publishing to the free and open Tableau Public space. Like you can see here, public.tableau.com. And this is giving us the view that we saw. So now I'm online, right? And it has all of the capabilities that we looked at earlier. One of the things that I want to point out before, I definitely went too long, but I want to point out here that there are some key settings when you publish, especially this one here. Because we're using Tableau Public, if you get the Tableau Professional software installed on your computer, that gives you some enhanced capabilities when you're building the dashboard, but does not give you any capabilities of where to save it. You can only save it to the public Tableau Public space, just like I did. You cannot, unless you pay much more money for a Tableau server local install or to use Tableau's cloud to be able to password protect or restrict users from interacting with your dashboard. So the one thing you can do is uncheck if you're using somewhat sensitive data, but the visualization is fine. You just don't want them to download your raw data. Make sure you uncheck allow others to download or explore and copy this workbook and its data. I'm just using public sources here, so it doesn't matter. But oftentimes, if I want to share the visualization but don't want people to download the data, then I'll make sure to go ahead and click that. Last, you'll see there is a share icon on the bottom here, and it gives us, this is the direct link you would send to someone, and this is the embed code to put in your blog, WordPress website, or anything. So even though we're down to probably a minute and a half, I apologize for that. But I'm not going anywhere immediately at noon. So if there are any questions, definitely now is the time for them. Oops.
Nothing in the chat yet, Josh, except amazing info and the same thank you.
All right. Well, I appreciate, Jennifer, you saying nicely paced. I really was concerned about going too fast, so I'm glad that was helpful. While we're here, the two main differences between Tableau Public and Tableau Professional, the desktop versions. With Tableau Public, you do not have the ability to save your work locally. That means that if you're working on a dashboard and you're halfway through and you want to save it for another time, you have to save it to Tableau Public. There's no way to save locally, where in the professional version, I can save to a TWB file, which is going to point to my data sources, or a TWBX, which is going to include the data sources in the file. That's the best way if you want to share it with someone. But of course, Tableau Public cannot even read these files. If you were to share a TWBX with someone, they also need Tableau Professional to read it. And the other, I think Tableau Public has a limit of 1 million records or 1 million rows per file. And it sounds like a lot, but once you start working with spatial data, if you start pivoting your tables, you're going to hit that 1 million in no time. All right. Well, if you guys think of any questions later, I think my email may be on that guide that we used, the one on GitHub. Just send an email. Definitely happy to help with anything mapping or anything Tableau. Thanks, guys.
Thanks so much, Josh. That was fantastic.